Good day, and welcome to part 1 of this webinar series on photogrammetry basics. I am Cedric Peterser, and I've been working the last 10 years as a drone pilot and 3D scan expert. Our primary tool to collect georeferenced point clouds is a digital camera. Most of us are familiar and are using the DJI Phantom 4 Pro products, but it can also be done with a handheld camera. Digital cameras mainly have two types of sensors: the CCD sensor and the CMOS sensor. The CCD sensor is found in mobile telephones as well as the older generation digital cameras. The CMOS sensor can be found in some of the mobile telephones nowadays, as well as your SLR or so-called single lens reflex cameras, as well as most DJI drones. This is what a CCD sensor looks like. And this is what a CMOS sensor looks like. Although we can use a CCD sensor in your mobile telephone to scan in an object and make it a 3D model from it, for accurate survey data, the CMOS sensor is the better sensor to use. Digital photogrammetry is the process to turn pixels into a point cloud. These pixels are photons of light that get stored onto the sensor into a data format like JPEG or RAW, and this in turn gets stored onto an SD card inside the camera. It is these pixels that we use in our photogrammetry software to eventually turn it into a point cloud. In order to get good quality point cloud, we need to obtain well-defined pixels. In this zoomed-in image, we see the pixels as small squares covering roughly 1 centimeter by 1 centimeter on the ground. This is part of an image that is taken from 40 meters above ground, and the entire image is covering about 28 meters times 42 meters. This image was taken with a Nikon Coolpix with a 1-inch CMOS sensor and through an 18.5mm lens. Motion blur and overexposure are the biggest enemies of photogrammetry. Motion blur and or out of focus photographs will cause noise as well as incorrect data. Overexposure or white pixels will cause incorrect data or sometimes even holes in the model. White pixels are dead pixels. You cannot do anything with a white pixel. You can't make it darker, and it obtains no information whatsoever. It is better to underexpose than to overexpose. Almost all digital cameras have got either a manual setting or an automatic setting. Most of the times you'll get away with slightly underexposed value on automatic setting, but in the rare cases where you do not get the right quality of pixels or the right quality of pictures, you can always go to manual settings and you can tweak the camera in order to get the data that you want. There are 3 main settings that you can use on a digital camera to be able to help you to get good quality, sharp pictures. You've got the ISO setting, the f-stop, and shutter speed. In the past, before the advent of digital cameras, one would buy rolls of chromatic film to load into the camera. Today, we can simulate those chromatic film rolls with the ISO setting on the camera. The ISO is the sensitivity of the sensor, where the lower the value, the higher the quality of the picture. The problem with too low of a value is that a slower shutter speed is required, and this can lead to overexposure of the picture. The problem with too high of a value is that the pictures will become grainy that can cause noisy point clouds and underexposure. So a good balance is often needed between shutter speed, ISO, and f-stop. The f-stop setting on the camera is how big the shutter opens. A small opening is a higher number, as you can see on the graph on the right. F8 is a very small opening. And a big opening, as you can see on the right at f1.4, is quite a large opening. We try to get as big as opening as possible. But again, in conjunction with the shutter speed, as well as the ISO setting, we want to try and avoid motion blur and overexposure. Shutter speed is for how long the shutter stays open. A long time, for example, 1/30th of a second, or maybe a minute or more, will let in a lot of light and overexpose the picture in normal daylight conditions. But this is sometimes used when the camera is placed on a tripod to take photographs at low light conditions, like taking pictures of the stars, for example. A short opening time, for example 1/4000th of a second, or maybe about 1/400th of a second, which is more or less what we would use on a drone. This will not let in a lot of light, and it can underexpose the picture. So by highering the ISO value and having a lower f-stop value, you might get the right type of exposure. This is just a graphic depiction of what a common shutter looks like. A good balance is needed between the ISO, f-stop, and shutter speed. In this picture, you can see there's good definition in the picture, it is slightly underexposed, and this will give very good data for 3D mapping. You can see that the f-stop is quite low. The shutter speed is at 320 parts of a second, and the ISO is at 200. These are all real good values, and they will work very good for a photogrammetry model. And then I have also in the DJI Go app set my exposure bias to minus 0.7. For photogrammetry, it's always better to slightly underexpose than overexpose. In the previous slide, we could see that I had set in the DJI Go app my exposure bias to minus 0.7. The reason for that is that most photogrammetry software like Pix4D or EXIF can work with darker pixels. But to have overexposed pixels, not many photogrammetry programs, if any, can actually work with them. One can always make a picture slightly lighter, but one cannot make an overexposed picture darker. To get to the exposure value setting mentioned in the previous slide, one has to open up the DJI Go 4 app. Once the app is up and running, you can go into the settings and you can scroll down to get to the exposure value or the EV setting there and press on the minus button until you get a value of minus 0.7 or even lower if desired. As you can see, the rest of the settings are on auto, where the camera will decide the f-stop, shutter speed, and ISO values. For most of it, this actually works quite well. But if one wants to have an aperture priority, one can go into that setting there, or a shutter speed priority, you can go into that setting, or for full manual, where you can adjust all the settings yourself, you can go into manual mode. Here is an example of a picture that was taken where the ISO value was way too high. In the next slide, we will be zooming into this area over here, and have a better look. Here I have now zoomed into that picture. I have right-clicked onto the picture to get the EXIF data. And here we can quite clearly see that a lot of detail has been lost and the picture is not sharp. This will be a grainy model with a lot of noise in the digital point cloud. One can see that the ISO value is at 1600, and that should have been possibly down to about 800 or even lower, depending on if it was windy or not when this picture was taken. Maybe raising the f-stop up to 5.6 also would have been a lot better, and it would have helped to get the ISO to a lower value. In this slide, we can see an example where the shutter speed was way too slow. We can see that it was only 30th of a second, and the ISO value was at 200. In this instance, it would have been better to higher the ISO to 400 and maybe up the shutter speed to 1 in 320. Here we have an example of a photograph with just the right parameters. The shutter speed was at 1 in 250, which is not too slow, and the ISO is at 400, which is not too high. Here we can see that we've captured all the detail, like the lines between these curbstones, and that we've got quite good detail on the draining grid. The auto settings on DJI drones work in most cases. It's fine for light wind to moderate wind conditions, when the ambient light is not too dark, on cloudy days, and as long as you remember to set the exposure value to between minus 0.3 to minus 0.7. When the auto setting is not going to work that well is in very strong wind conditions. As the drone would be moving around a lot in the sky, you will have a big risk for motion blur. You're going to have to up the shutter speed and adjust the ISO to get the right exposure. Remember, motion blur must be avoided at all times. In low light conditions, you will get underexposed photographs, so you will need a higher ISO value and adjust the f-stop and shutter speed to eliminate motion blur and avoid underexposed photographs. The most difficult situation is on bright sunny days with strong shadows. In this case, it'll be better to lower the ISO and to have a large f-stop opening, in other words, a low f-stop value, as well as a very fast shutter speed. If you do not have a lot of experience, or if you have any doubts in what the camera settings should be, it's a good practice to take the drone up to the planned flight height, rotate the gimbal down, and take a few test photographs to see what the photos look like. Play around with the settings and see which ones work the best for you. But you have to take the drone up into the sky and rotate the camera down. You will not get reliable information with the drone on the ground and the camera facing forward. There are a few things that don't work well with photogrammetry. Photogrammetry doesn't like reflecting surfaces, like water, buildings with glass facades, high gloss roofing, solar panels, glass in general. Anything that's moving, like water, vehicles driving while you are scanning, or any object that is not standing still. Thin structures are also problematic, like wires, wire fencing, cables, radio masts, handrails on staircases, balcony rails, and so on. And repetitive patterns, like corrugated roofing, especially when it's new, wooden plank facades, or any other repetitive pattern that will make it difficult for the photogrammetry software to stitch. It is always better to fly low and slow rather than high and fast. At the end of the day, it'll be the size and the quality of the pixels that will determine the accuracy of the model. in conjunction with ground control points, of course. When you fly low and slow, there will be less chance of motion blur. And the pixel size, or so-called GSD, ground sense distance, would be smaller, hence higher accuracy on your model. The recommended flight height for a Phantom 4 series drone is between 40 and 50 meters above ground. Anything higher than 50 meters, you will see an exponential decrease in accuracy. At between 40 and 50 meters above ground, you also get a fair yield on flight time versus area covered. Don't fly too fast. At 40 meters above the ground, keep the speed below 3 meters per second, and at 50 meters above the ground, keep the speed below 5 meters per second. In this way, you will definitely minimize the risk of motion blur. So, to sum it up, we want good, sharp pixels. We can use the three main settings on the camera to get what we need: the ISO, the f-stop, and the shutter speed. And in conjunction with this, we need to fly low and slow and have lots of overlap. In our next part, we will go through flight planning, drone setup in GS Pro as well as DJI Go 4, basic tips and tricks, common problems and workarounds, troubleshooting, and ground control points. That is all for now. Thank you for your time.